Good evening. This is Ken Rosever. I'm going to be out of town, so I'm not going to get to do this review with you. And so I thought I'd put something online that'll help you out. I got to, with my Tuesday-Thursday class, go through all this and also conduct the review of going over some specific problems in class. Now, I won't be able to do that with my other two sections because of an obligation I have, but I do want to run through an outline of what you can expect on Test 1. And I've written those out here. Unfortunately, I don't have a document camera, and rather than taking the time to write this again with a stylus onto my computer screen, I'm just going to run down these items. And then in the second video, I plan on making two. I'm going to do a little bit of review of some of the stuff in 1.6. Okay, so what's going to be on the test? You can expect some problems that require you to convert between set builder and interval notation. For example, set builder notation such as this, which says the set of values such that x is less than -3 and x is a real number. This set builder notation could be converted to this interval. Since it's x is less than -3, we understand that it's anything less than -3. Well, that begins at -infinity. It goes to -3 and gets a bracket because it includes the endpoint, the boundary. I will also give you a problem where you're required to take an interval. This is a half-closed interval. It is the set of numbers, real numbers, between -2 and 5, including 5, but not -2. So there are two ways that we can express this. There are probably more, but I'm looking for some symbolic representation, not words. So one way you could do that is the set of values, the set of x's, with the condition that those x's are greater than -2 and less than 5 in their real values. Or you could write it, instead of writing it as a compound inequality, you could write it as, I apologize for the background noise, that's my two dogs playing. Okay, anyways, you could also write it like this: x is greater than -2, that's the same thing this says, and x is less than or equal to 5. So there you go, you're going to need to know how to do that. Another thing you'll need to know is examples, differences, how to describe the sets of natural numbers, integers. Actually, I should say the subsets of real numbers that we discussed. Those subsets were the natural numbers, the integers, the rational numbers, the irrational numbers. So be able to describe them, be able to give examples. I'm going to have a fill-in-the-blank question or something like that that relates to it, where you'll either have to give an example, give a difference, or give a description. Just as a reminder, the natural numbers are the set of values that begin with 1 and go to infinity, that are only whole numbers, numbers that are naturally occurring. The integers, represented with a z, are the positive and negative whole numbers. Whole numbers include 0. So, and actually technically 0 is a neutral number, so it's the positive and negative natural numbers and 0 make up the integers. The rational numbers are any real numbers that can be written as a fraction are rational numbers. Irrational numbers are real numbers that can't be expressed exactly as a fraction. Some examples are the square root of 2, pi, e, square root of 7. Actually, the square root of any prime number is a irrational number. So that's what you can expect in that area. Moving on, you're going to have to know your definition of relations and functions, specifically what makes a relation a function. And the answer to that is each x has but one y, or each element of the domain has but one element one corresponding element in the range. And the test for that is the vertical line test. If you look at this relation here, it's a set of points, so it's considered a relation. This one x here has a y at this level, but also has a y at that level. So if I drew a vertical line, it would hit both those places. The vertical line test would tell me that this is not a function because a vertical line hits in more than one place. So when you fail the vertical line test, you are not a function. If you pass the vertical line test, it means you only hit in one place at a time, and you are a function. I'm going to give you a question on the vertical line test. You need to know that it checks whether each x has only one y. You fail it if your x has two y's. You don't fail it if your y's have if your y has two different x's. That's okay. You can see this y here and this y over here are the same y. They're both at this level, right? So, but what's different? This y has both this x and this y has this x. And so you'll learn later on in the book that that means this is not a one-to-one function because it doesn't pass the horizontal line test, but it is a function because it passes the vertical line test. You'll also be required, let me fix that, to put an equation in function notation and then find f of x for some x. I gave an example like this in the notes. I gave you a quadratic and two variables. We had to adjust it, get it so that it said y equals. Having done that, how do you put it in function notation? You take the y out because y is a function of x, and you replace y with f of x. And then whatever value I asked for, you just plug that in for x here and for x over there, and it'll tell you f of that value is whatever it turns out to be. You will be required to know your distance formula and midpoint formulas and use them. I don't think I'm going to ask you a question on Pythagorean theorem because that is what the distance formula is. That is where it comes from. So I'm probably not going to ask you both. There will be a lot of questions because I put a big emphasis on graphs with f of x and g of x and y of x and solving equations by graphing and understanding what that means. And why did I do that? Because that is a skill you will need throughout the course. If you look at the title of the book, it says, let me bring this up. I don't know if you can read that, but it says a graphical approach to college algebra. So throughout the course, we'll be emphasizing the connection between the analytic side of algebra and the graphical side of algebra. And so I'm really giving you a head start by really emphasizing that here. So you will see questions like, what is f of 2? You'll be given a graph. You'll find it. It's easy. You'll be asked, where is f of x equal to 0? Basically, find the 0 of the function is find the x-intercept. Here it is, right here, whatever that value that is what you'd put there. Where is f of x equal to g of x? You should know at this point that that is at the intersection, and the question is asking for an x value. Okay, where is f of x less than or equal to g of x or something of that nature? You have to ask yourself two questions. You know it relates to the intersection, and you have to decide, is it before or after the intersection, and is it including or not including that intersection? In this case, f of x is less than g of x before the intersection, so whatever value this was, we'd say negative infinity, comma, that value, and because there's an equal sign here, we put a bracket. And that value would be the x value, not the y value. For y1 minus y2 is greater than 0, something of that nature, just move the y2 to the other side, and then it's in a form that you're used to seeing. And same thing if it's like this. The other question you may be asked, and actually it's not a maybe, you will be asked, the domain and range of some functions. Just keep in mind, if it's linear, the domain and range are negative infinity to positive infinity. If it's nonlinear, you have to be a little more careful. In the case of a parabola, the range does not extend beyond the highest or lowest point. This parabola has a lowest point, So the range begins here and goes upwards to positive infinity. You will have a question like that, and it'll either be like a absolute value v function, or it'll be a quadratic function, and it'll be upside down or right side up. Either way, just watch out on the range. You will have a question like this. This is a rational function. Actually, technically it's not rational because the only variables in here are the x's, and those x's aren't in the denominator. But you can see it's a equation, or actually an inequality, that will be composed of some fractional pieces. So you're going to have to use the LCD. I put an example in here. I said, suppose that I gave you 2x plus 5 over 3 minus 4x minus 2 over 2 is greater than or equal to 5. Now, there's a lot of things you have to watch out for. Okay, because this is an inequality. If at any time you divide by a negative, you'll have to flip the direction. Also, because there's a minus here, and there's a minus in there, and this minus is going to get distributed after you multiply through by the LCD, which happens to be 6 here. 2 goes into 6 3 times. Well, that 3 is not a positive 3, but a negative 3, so you have to distribute the negative 3 in to this term and to this term. Watch out for your negatives, both when you're distributing and when you're dividing. And your answer here will be an interval notation because this is an inequality. Make up some problems on this. Change A, B, C, D, E, F, and G, and just practice. And watch out to make sure that if there's a minus here, that you're distributing it. You can make this a minus, you can make it a plus, whatever, but that's a heads up. Alright. I'm going to give you 2 review questions with graphing linear equations. One by using x and y intercepts. The y-intercept is always f of 0, but in a linear equation, when you're dealing with x and y's, you find the y-intercept by setting x equal to 0. You find the x-intercept by setting y equal to 0. You'll also need to be able to graph using slope-intercept form, and that'll be all of that will conclude the part of the test that you are not allowed to use a calculator on, because I want to see you graph those by hand. The part of the test you are allowed to use a calculator will be composed of the following pieces. You'll be asked to estimate a nth order root, or in this one it's a fifth root of 6 to so many decimal places. You're not going to look for a fifth root button on your calculator because it's unlikely you'll find it. So the key to this is remembering that a fifth root is a 1/5 power, and you need to put that 1/5 in parentheses. If I ask you the third root of 92, that would be 92 to the 1/3 power. I'm going to ask you to solve a nonlinear equation by intersection of graphs methods. You saw that we did that a lot in the notes. We played around with that, and that's where you set the left side equal to y1 and the right side equal to y2. You'll also be asked to do one by the x-intercept method. That's where you move everything to one side of the equation. You call that side y1, you graph it, and you find the 0 being the x-intercept. And lastly, well, not lastly, you'll have some word problems out there. You can expect a chemistry type problem. You might see one like that TV one or something with a similarity. And you can also expect to see problems where you're asked to solve for a specific variable. That skill is critical, especially as we get into finding inverses later on in the year. So spend some time. Watch the next video as I go over some of those. I put links online in PAL to some of the word problem types that you can review if you've been having trouble with those, and you will also find in your My Math Lab a new homework assignment entitled Review for Unit A. So try that out. Try not to use the learning aids on there, and do your best. And I'm going to record that other video. Bye-bye.